All right, let's talk about one of the most mind-bendingly creative ideas in all of AI, Generative Adversarial Networks, or as you probably know them, GANs. These are the reason an AI can dream up faces, create art, and even compose music that's never existed before. So how on earth does it work? So here's the big question that stumped researchers for a long time. We're pretty good at teaching a machine to see a photo and say, that's a cat. But how do we teach it to imagine a cat? To create a picture of a cat that has never, ever existed? Well, the answer, it turns out, is to make two AIs play a brilliant and incredibly competitive game against each other. So, what are these things? When Ian Goodfellow came up with the idea back in 2014, it wasn't just a small step forward, it was a complete game changer. Before GANs, AI was mostly an analyst, sorting through data that already existed. But after GANs, AI became an artist, capable of creating brand new, totally plausible data all on its own. At its core, a GAN is basically a duel. It's a system with two neural networks locked in a battle. This whole setup is actually inspired by something called a min-max game in game theory, where you have two opponents with completely opposite goals, and in trying to beat each other, they actually force each other to get way, way better. To really get this, there's a fantastic analogy that makes it all click. I want you to imagine a high-stakes game of cat and mouse. On one side, you've got a brilliant art forger, a counterfeiter, trying to create fake money that's absolutely perfect. And on the other side, you have a detective, the cop, whose entire job is to spot even the tiniest flaw in those fakes. So, meet player one, the generator. This is our counterfeiter, and when it starts out, it is terrible at its job. It's just creating random static, total garbage. But its one and only mission in life is to get better at making fakes. Fakes so good that they are completely indistinguishable from the real deal. And then you've got player two, the discriminator. This is our detective, our cop on the beat. The discriminator's job is to be the ultimate critic. It gets shown a whole pile of stuff, some real banknotes from the bank and the counterfeiter's latest forgeries, and it has to make a call for each one, real or fake. Now, here's where the magic really happens. Their goals are in perfect, direct opposition. The counterfeiter only wins when the cop gets fooled. Every single time the cop correctly spots a fake, the counterfeiter gets a little hint about what it did wrong, and it learns. And every time a fake slips by, the cop learns to look even closer next time. It's this constant, escalating arms race that powers the whole system. And of course, this isn't just a one-and-done kind of game. Oh no, this is played over and over and over again. Thousands, sometimes millions of times, in what we call a training loop. And with every single round, both the counterfeiter and the cop get a little bit smarter, a little bit faster, and a whole lot better at their jobs. So you might be wondering, where do these fake images even come from? Well, the generator, our counterfeiter, starts with a very simple ingredient, just a random string of numbers. We call this the latent space. You can think of it like a secret recipe, or maybe a unique DNA code. The generator's entire job is to figure out how to transform that simple, random code into a complex and convincing final product. The game itself follows this really clear four-step loop. Step 1, the counterfeiter creates a new batch of fakes. Step 2, the cop looks at them mixed in with some real ones. Step 3, the cop makes its judgment call. And step 4, this is the most important part, both of them get feedback. The cop is told if it was right or wrong, and the counterfeiter gets clues about why its fake didn't pass inspection. And then the whole thing starts right back at step 1. Okay, the theory is cool, but seeing this in action is way better. So let's actually watch a GAN being trained. We're going to see it try to create handwritten numbers using a really famous dataset called MNIST. Now pay close attention to how our counterfeiter goes from being a complete amateur to a master forger. Okay, here we are in Epic 1. That's just a fancy word for the first round of training. And as you can see, the output is, well, it's just static. It's a mess. At this point, the generator has absolutely no clue what a number is supposed to look like. And the discriminator, the cop, it's having a really easy day at the office, spotting every single one of these as a fake. All right, let's fast forward to Epoch 10. Now things are starting to get interesting. It's still really messy, but look, you can start to see these vague shapes. Some loops and lines are beginning to form. The generator is catching on. It's learning that numbers have structure, that they aren't just random pixels. It's getting its first real clues. Now let's jump to Epoch 50. And wow, look at that. We have actual recognizable digits. I mean, they're not perfect, right? Some are a little wobbly, a bit weird looking, but they are undeniably numbers. At this point, the counterfeiters' forgeries are getting good enough that they can actually fool the detective every now and then. And here we are at epoch 100. The transformation is pretty much complete. These generated digits are crisp, they're clean, and they look incredibly real. The generator has become so skilled that its creations are now a serious challenge, even for a really well-trained discriminator. The game has totally leveled up. So making little handwritten numbers is a fantastic proof of concept. But what happens when you take this idea and you scale it way, way up? Well, that's where GANs go from a cool experiment to a technology that is genuinely changing the world. The range of applications is just staggering. GANs can generate photorealistic faces of people who don't exist. They can turn your vacation photo into a painting in the style of Van Gogh. They're behind the technology that enhances blurry, low-resolution images. And it's not just images. They can create synthetic medical data to help train other AIs without violating patient privacy or even compose brand new pieces of music that have never been heard before. But, and this is a really important but, with this unbelievable power to create comes an equally huge responsibility. We just can't talk about how amazing GANs are without also talking about the profound and tricky questions they force us to ask. Think about it. When an AI can create a perfect fake, what does that do to our shared sense of reality? This technology forces us to grapple with some really tough questions about misinformation, about trust, and about what it even means for something we see online to be real. Hernan Diaz-Rodriguez really hits the nail on the head in the book this analysis is based on. He says GANs represent a balance between the pursuit of realism and the preservation of truth. And that's just perfect. It's this constant tension, this tug of war between pushing the limits of what's possible and our fundamental need to know what's real. And all of this leaves us with a final, really big question to chew on. As these amazing creative tools get more powerful and easier for everyone to use, who is ultimately responsible for what's real? It's a challenge that isn't just for the engineers and the scientists anymore. It's a challenge for all of us.